So let's start solving this problem. Okay, this is the third problem for our chord line segment problems. Okay, for our module for today. So we have here Lana and Ty had a tire problem. They needed to find the length of a metal rod that impaled the car's tire that they have. So shown below are two concentric circles representing the tire with a radii of 8 inches. So this is the radii of the small circle, or the plate of the tire, and then we have 12 inches for the radius of the entire tire itself. And the smaller circle divides the chord of the larger circle into 3 equal parts. This is a very important clue. Okay, so what did it say? The smaller circle divides the chord of the larger circle into 3 equal parts. Okay, we need to find the length of the metal rod that got stuck on the tire. Okay, so how are we gonna do that? First, let's look at the most important clue that we have here. The chord, or this metal rod that's stuck inside of the tire, okay, divides the circle into 3 congruent or same sides, or 3 equal parts. Okay, so therefore, if this is going to be x, so therefore for this problem, if this is going to be x, okay, so this is going to be our x for this problem, therefore this must also be x. Okay, so therefore the entire length of this part, okay, from here to here, let's say this is point B and this is point A, so therefore the length of points A and B should just be equal to x plus x, and that should give us 2x. Yeah, so therefore, this small line segment here, that's x, and this line segment here and this line segment here are just gonna be the same, since they are on one line, okay, one straight line on the circle. So that's gonna be x plus x, and that should give us 2x for this line segment over here. And what's the clue for this one? It's been divided into 3 equal parts on the concentric circle. So therefore, okay, let's not, this figure that we have here is not to scale. But for this one, this should also be 2x. The measurement of this side should also be 2x. And this side over here, this should also be 2x. Yeah, let's say for example, we can name this as point C and point D. So therefore, the measurement of CD is just gonna be equal to 2x plus 2x plus 2x. So that should give you 6x. The measurement of CD is just equal to 6x for that one. And we need to find the value of x. If we're going to try to maximize this problem, we can see here that we have another variable length that we do not know. So how do we find the measurement of this length? Okay, we can name it as y. Okay, so therefore, if we're going to try to imagine, or we're going to try to reconstruct our figure here in a very zoomed manner, okay, so therefore this is going to be our triangle, and this is also going to be another triangle, and they are both right triangles. Okay, these two triangles are both right triangles, and the measurement of this hypotenuse is equal to 12, and the measurement of this other hypotenuse is equal to 8. Okay, and the measure of this line segment over here, so that's just x, and the measurement of the line segment here, so that should be 2x for this problem, and the measurement of this one is going to be equal to y. So using similarity of triangles, we can create a very similar, or we can create an equation, okay, that shows the relationship between the two similar triangles for this one. Okay, let's say for example this is gonna be point let's say this is gonna be point E, point F, point G, okay, and let's say for example this is gonna be, this point A. Okay, so E, F, A, and then C, to keep it consistent with the naming rules that we have here. So therefore we can say the triangle CEF is similar to triangle AEF on this problem. And we can solve for the measurement of the value of x if we create an equation, or rather if we create two equations that represent the proportioned or the proportional segments of these two triangles. So therefore, if we have your CEF and we have a right triangle, of course with right triangles we know this all the time, we can use the Pythagorean theorem. So a squared plus b squared is equal to c squared. Okay, and that's gonna be equal to, or that's just gonna be the same with the other triangle. A squared plus b squared is equal to c squared. Okay, so for CEF, we have here CE. This is the hypotenuse, so that's 12 squared is equal to b squared, so that's gonna be y, or y squared. Then we have here, what's 2x plus x? That's gonna be the height of the triangle of, that's gonna be the height on the triangle CEF. So that's gonna be 3x squared. Okay, so this is gonna be the formula for the segments on the triangle of the bigger triangle CEF. And for triangle AEF, so that should give us the hypotenuse is equal to 8, so that's gonna be 8 squared, and the height is just equal to x squared, and the base is just equal to y squared. Okay, so this is gonna be for the formula for triangle AEF. Okay, and therefore we have here these two equations that we can simplify much further. Okay, so what's the square? What's quantity 3x squared? So that should give us 9x squared plus y squared is equal to 144. 12 squared is equal to 144. And then we have your x squared plus y squared is equal to 64. Okay, we can solve for the value of x for this one by canceling out the y squared. So we can multiply the second equation by negative, okay, by a negative sign. So this is going to be negative x squared minus y squared minus 64, and then we can add. Okay, so we can add after turning those numbers into negative. Okay, so therefore this is going to give us 8x squared is equal to, so it's 144 minus 64, so that should give us about 80. There we go. So that should give us 8x squared is equal to 80, dividing both sides by 8. So therefore x squared is equal to 10. Since the value that we solve for x squared is equal to 10, we can take the square root of both sides, and what's the square root of x squared? That's just equal to x, and that will result to 10. Square root of 10 rather. So therefore the value of x is equal to square root of 10. Since we have here the values of AF is equal to x and CA is equal to 2x, we can just simply substitute our solved value of x to get the measurements of CA and AF. And that should give us 2 times square root of 10 and square root of 10. And what's 2 square root of 10 plus 1 square root of 10? That should give us 3 square root of 10. And therefore, that's the value of our CF, the half of the rod that was stuck in the tire. And if that's the half the value, we can multiply this by 2 to get the entire length of the rod that was stuck in the tire. So therefore, for this one, this is going to be CF times 2. Okay, that will give us CD. And since we know that the value of CF is equal to 3 square root of 10, we can solve for the measurement of CD here, and that's just going to give us 6 square root of 10. 6 square root of 10 inches is the measurement of CD. And if you want the decimal value for that, the exact decimal value, and that should give us essentially 18.97. So 18.97 inches is the length of the rod that was stuck in the tire on Lana and Ty's car. And that's how we solve this problem.